Hello Year 10. We are on to new content now, and we are going to kick off, while I have the time to do it, trying to make some videos for you. So welcome. The first one we're going to do here is surface area leading into exercise 6D. Now, surface area is essentially you have some sort of object and you want to paint it, or you want to tile it, or you want to spray paint it, or you want to do something to this surface. You want to know how much surface there is on the outside of your object. That is surface area. It's the area around the object, right? And when you're dealing with different objects, I mean, look at this. This is almost a cylinder, not quite a cylinder because it's got this thing hanging off. I'd have to break that off, but I'm not that vicious while doing a video. The surface area of this object is going to be, that little surface on the top, that little surface on the bottom, and that surface going around it. I've now dropped on the floor. All right, that's surface area. So without going back any further than that, because I think most of you are hopefully okay with the concept of surface area, I'm going to give you a couple of technical definitions. The text is getting a little bit more technical occasionally. It says that a prism is a polyhedron with a uniform cross-section. And, I know what a uniform cross-section is. I'll get to that. But the polyhedron, what exactly is the definition of that? It leads you to more questions than what you started with. Apparently, a polyhedron is a three-dimensional shape with flat polygon faces, straight edges, and sharp corners or vertices. So there you go. That's what a polyhedron is. Uniform cross-section is just this idea that if you chop this shape at any particular space, any particular point, if you chop it, you'll get the same shape. It's uniform, meaning the same. So if I chop this object at any particular place going down it, you should see a triangle. Think about that. If I chopped it anywhere there, I'm still going to get the same triangle. So it's a uniform cross-section. Same with that one there. Up there, if you chopped it anywhere in particular, you'll end up with a square. Right? So these two are examples of prisms. That's a triangular prism because if you chop it anywhere, you're going to get a triangle. And that one's a square-based, what do we call that? A square-based prism. Because anywhere you cut that, you're going to get a square. All right, cylinder, yeah, it just says you get a circular cross-section. So, if you chopped that at any particular point, chop, 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 you're going to get a uniform cross-section again, but it's always going to be a cylinder. A circle, sorry, it's always going to be a circle. You chop it anywhere, you're going to get a circle if you look at the shape. All right, so from there, surface area, if you don't have a formula for the particular object you're looking at, you'd find the area of each little bit of the object and add it together. And fair enough. All right, that's what you do if you don't have a formula. For some simpler objects, it's not too bad to have a formula for surface area. So let's quickly derive a few formulas that you could use for some of our more common objects: the cube, the rectangular prism, and the cylinder. So here we go. So for a cube, let's call, you remember that for a cube, all dimensions are the same. The length, the width, and height, they're all the same. We're going to call them S. Now, if I was looking at one particular face here on the front, what would the area of that be? It's side times side. You'd say the area of the front there is side squared. But every face on the cube is the same. Every face, the area is going to be side squared. So how many faces are there? You might want to draw a net. The net is where you open it out and flatten it out. If you flatten out a cube, you get something that looks a little bit like this. They're not very good squares. But you get the idea. You end up with 6 squares. So a cube, the area is going to be 6 times the face. So the surface area of a cube is simply 6s squared. 6 times side squared, where side squared is the area of each face. For a rectangular prism, things get a bit weirder. So this is where we introduce length, width, and height. So I'll call it length across here, width here, and height here. Now, if you think about it, the face, because we're looking at the surface, right? the surface on the face here is the same as the one on the back. The surface here on the right is the same as you'd see from the left. And the surface there on top is the same as the one on the bottom. So effectively you've got three different faces and each of them is repeated twice. You've got two copies of three different faces. So let's consider the area of those three different faces. This one on the front here is length times height. Length, height, the area here is length, height. This one on the side here, it's width by height. So that one there, the area is width, height. And on the top here, it's going to be length times width. Now remembering you've got to have two copies of each face, you end up with surface area formulas that look a bit like this. We have 2 times length width plus 2 times length height plus 2 times height width. Now you can mix those letters around any which way and the texts do, but the concept's the same. In here I should have each combination of the letters that's possible. Since there's a common factor of 2, often you can just extract that out. And so we can write the surface area as 2 in brackets length width plus length height plus height width. Think about that. If I expanded that back out, I'd get 2 times everything. I'd get that original formula back. For cylinder, things are interesting. Let's do that one next. So we have a height there. And as with all circular things, we have a radius. Now the top and bottom, so the top and the bottom are the same. What's the area of a circle? I hope you remember it's pi r squared. So the top and the bottom give us 2 pi r squared. That's fair enough. So that bit there, the area is pi r squared on the top and the bottom. This bit here is a little bit quirkier. If you have a cylinder and you flatten it out, it's best shown with a piece of paper if I don't have anything too sensitive here. There we go. So if I have a cylinder here and I was to flatten it out, the round bit of a cylinder becomes a rectangle. So it's actually a rectangle, the area of that bit that goes around the cylinder. But the dimensions of it, well, that's another issue. Height's one of them, but how do I know the distance around here? It's actually the circumference of a circle. And so you have to remember the formula for a circumference of a circle, which is 2 pi r. So the area of that rectangle there, a rectangle's length width, but it's going to be 2 pi r times the height, because the length around there is 2 pi r and the width is the height, right? So that rectangle, the dimensions of the rectangle that you get from the cylinder when you flatten it out, it's 2 pi r in one direction and height in the other. So it's 2 pi r times height. That's how we find the area of that rectangle. So putting that together, the surface area of a cylinder is the 2 pi r squareds, that's the top and the bottom, plus the rectangular component, which is 2 pi r h. They have a massive amount of common factors there. They have a 2, a pi, and an r in common. So you will see in the text and elsewhere, often you'll see it quoted as 2 pi r, r plus h. Because 2 pi r times what would give 2 pi r squared? It's an r. And 2 pi r times what would give us 2 pi r h? It's the h. So you'll also see that quoted as the surface area of a cylinder. So I'm going to do a couple of examples quickly, or try to do them quickly. So hopefully you are a little bit more comfortable with the whole surface area situation. Hopefully many of you are already okay with surface area. So I'm going to have to rub some stuff off. No hard feelings. So I might do a rectangular prism first. I'll do 7.2 meters by 4.6 meters and 2.8 8 meters. There we go. So if I'm asked the surface area of that, a rectangular prism, I put labels on it. There's length, there's width, there's height. And you should always be doing this. Anyone who's not doing the following process, go on guys, not at this stage, we're at year 10. All right, year 10 mathematical methods. First step, I should always see a formula. Where there is a formula, there should be a formula. So I expect in this case to see surface area is 2 length width plus length height plus height width or similar. Next step, we substitute in the values. Length is 7.2, width is 4.6, length is 7.2, height's 2.8, height is 2.8 and width is 4.6. Alright, so from there we can plug that in our calculator. I'm perfectly fine if you put it in at this stage. 7.2 times 4.6 plus 7.2 times 2.8 plus 2.8 times 4.6. Just put it all in the calculator, equals, and we've got an area. Got to remember to include your usual units here. In this case, it's meters squared. All right, because we are dealing with area. All right. Next up, I might do a cylinder quickly and then possibly something weird, if I can think of something weird. So, there we go. A cylinder that has a diameter of 3.6 centimeters and a height of 1.5 centimeters. A cylinder is another one that we have the formula for surface area. So we should be putting that first. Surface area is 2 pi r in brackets r plus h. Now, I've deliberately given you a trick there. I provided the diameter rather than the radius. But if the diameter is 3.6, what's the radius going to be? Half of that. So the radius will be 1.8 centimeters. We need to make sure that we put in that rather than 3.6. And this here is the height, that's h. So I've labelled everything. So next step, you'd see 2 times pi times the radius, 1.8, times, in brackets, 1.8 plus 1.5. So simple substitution. I've just put the values into the formula. Now I've got my technology. Make sure to use the pi button when you're doing calculations involving pi. So it's shift the times 10x on most of your calculators. 2 pi times 1.8 times, well, that's going to be 3.3, isn't it? Right, which gives me 37.32. So 37.32, and remember your units, it's area. Area is two-dimensional, thus we have centimeters squared for the squared units. All right, so from there, I'm tempted to do one more. I'll do a weird one, and that'll be it for this lesson, and you need to go forth and enjoy 6D on your own. All right, so, do we do one similar to what we see there? All right, I'm going to do one similar to that. We're going to have a rectangular prism with a cylinder. Oh no, a square-based prism. Okay, we'll do a square-based prism. With a cylinder on it. clean that up on the side there. All right, so I'm going to make that, so that's the same, 2.4 kilometers. This is massive, really, really massive. 2.4 kilometers. And I'm going to make that 620 meters for the radius, and the height here can be 1.7 kilometers, and this height here can be 1.9 kilometers. Now this is a little bit of a tricky question. This is indeed quite a bit harder. So logically, what I would be thinking here, still doesn't look right, does it? I'm not happy with my sketch. Anyway, all right. Now, if we think about this logically, the surface here, area here has to be the square-based pyramid, square-based prism, sorry. The square-based prism at the bottom, it's got to be the surface area of that plus the surface area of the cylinder, subtract that circular base. You see that circular base there isn't going to be included. And you actually have to subtract it twice because it's not part of the surface. See, it's not part of the surface for the cylinder, and it's not part of the surface for the square-based prism. We actually have to subtract it twice because, yeah, it's not part of the surface for either object because they're connected. So we have to be really careful with that. So that's the logic of what I'm going to do. What I'm now going to do is going to look quite large. So the formula for a square-based pyramid, we may as well just use the same as a rectangular prism. So as with before, surface area of a rectangular prism plus the surface area of a cylinder, but then we need to subtract 2 times the area of a circle. So 2 lots of pi r squared for the right circle. All right, so that's our square-based pyramid we're going to figure out. That's our circle, our cylinder, and then that's that surface there that we need to remove twice. Sound like fun? There's going to be quite some values substituted in here. It's going to be a big thing for your calculator. So thinking about the square-based pyramid, there's length, there's width, there's height. Thinking about the cylinder, I'll know I've got something in different units. Everything else is in kilometers, so I'd probably make that in kilometers. So the radius I'm going to call 0.62 kilometers. Remember, we divide by 1,000 to make it kilometers. So that's going to be our radius. That's our height of our cylinder sitting right there. And again, that circle there that we need to remove twice, the radius is still the same there. Next step, I'm going to substitute a whole stack of values into that. So it's going to be 2.4 times 2.4 plus 2.4 times 1.9 plus 1.9 times 2.4. So that's just the rectangular prism component. Plus then 2 times pi times the radius, 0.62, times, in brackets, the radius of 0.62 plus the height of 1.7. So that's the cylinder part. And now to remove those circles, it'll be subtract 2 times pi times 0.62 squared. Be very careful. Quite a good chance of me making an error doing this. Well, how about you guys? So let's do this. 2 in brackets, 2.4 times 2.4. I hope you're doing this at home. Plus 2.4 times 1.9 plus 1.9 times 2.4. Close brackets. plus, so I'm up to here, 2 times, use the pi value, don't estimate pi, enter it in properly, times 0.62 times, open brackets, 0.62 plus 1.7, close brackets, subtract 2 times pi times 0.62 squared. Now I really hope that that's going to be correct. That's what it gives me. Any corrections, send them to me so I can embarrassingly have to fess up to my own mistakes. I'm getting 36.38 kilometers squared. Remembering this is the whole point was we were working out the surface area of this object. And that indeed should be the surface area of this object. All right. I hope you found this particular lesson enlightening. That's a revision of surface area of objects up to and including a hideous thing. Enjoy. Have fun. Bye.